Hello everyone. Today we will be discussing the topic of robots and automation. My name is Professor Harshal Kanekar and I am from the Department of Electronics and Communication Engineering from Tulsiranji Gaikwad Patil College of Engineering and Technology. So the content of today's video is the first we'll be discussing about introduction of the robot, and then we'll discuss the 7 criteria of defining a robot, and later we'll discuss about the few of the major components that are used in robots. We'll also discuss about the types, what are the types of different types of robots, and later we'll discuss about robot vocabularies, in which we'll discuss middleware and its basics, and later we'll discuss about giving robot instructions, how we give instruction to the robot. So let's begin with what is a robot. So robot is a programmable machine capable of sensing, processing information and performing actions accordingly. So what this means is that if a robot is in a certain environment, it must be able to sense in which environment it is, like the changes in the environment, where it is. It should see or feel or process the information accordingly. So processing is and sensing is done through sensors, which is very important. If a robot need to perform certain actions, it must sense the information and process and give the input to the microcontroller accordingly. That it must do, and later it should be able to perform actions accordingly. Action in sense, it should be able to do certain actions that the user is giving or it is programmed to do. So these are the few things that a robot must be capable of doing. There are basically 2 types of a robot. Firstly is teleoperated and second is autonomous robots. So telerobots are remote controlled robots, whereas telerobots are teleoperated. In first category, which is remote controlled, it can be wired or wireless, and the second category is autonomous robots, which are perform actions without human intervention. So there are 2 types in that. First is logically controlled and second is behavior based. Later we'll be discussing about the 7 criteria of defining a robot. So not all machines are robot. There are few criteria that a machine must fulfill to be called as a robot. So what are these criteria we'll be discussing in here? First is that it must be capable of sensing its external and internal environments through programming. So if a robot is in a certain environment, it must be able to sense its internal and external environments to be useful. That can be done through sensors. And the second point, it should be reprogrammable behavior. Actions, control are the results of executing a program set of instructions. It should be programmable. If we need to do certain changes in the future, it can be done without we need to change certain hardware. We can do that through programming only. Third point is that it must be capable of affecting, interacting with or operating on its external environment through programming. So if a robot is to be useful, it must be able to interact with the environment in which it is, or do changes in that environment to be useful. So it is one of the criteria to be fulfilled. Fourth point is that it must have its own power source. So power source is very important. So if a robot need to perform certain actions, it should have its own power source to be operational. Fifth point is that it must have a language suitable for representation of discrete instructions and data as well as programming. So for a robot to be given an instruction, there must be a programming language through which a programmer can give the information to the robot to perform certain actions. So it must have certain language so that we can give instructions to the robot. Sixth point is that once initiated, it must be capable of executing its program without the need of external intervention. So once the programmer programs the instructions and give it to the robot, it must perform certain actions in that environment without any human intervention. So it can be autonomous. And lastly, it must be a non-living machine. So these are few of the 7 criterias that a robot must fulfill to be called as a robot. So there are basically 3 types of robots. First is aerial robots, second is ground-based robots, and third is underwater robots. So aerial robots are the robots which can travel in air and perform certain actions, and ground-based robots are the robots which do certain things on the surface level only. And lastly, there are underwater robots which can do changes or travel underwater. Aerial robot examples of aerial robot are UAV, which are unmanned aerial vehicles. Those are used by the army for surveillance and different purposes. And the examples of underwater robots are AUV, that is autonomous underwater vehicle. It can perform certain actions underwater. Aerial and underwater robots, as they are doing certain work in a different environment, those are pretty difficult to be made and operated than ground-based robots. But it basically depends on the situation it is in. Now we will be discussing about robot controllers. What are robot controllers? What are the few basic components that are present in each and every robot? There are 4 components which are present in the robot. Firstly, there is microcontrollers, which is the brain of the robot, and it is very important part through which we can give instructions and programs to the robot. Then second is sensors, through which the robot can take input in certain environment. Third is actuators, through which the robot can perform motion and through motors and all. And lastly, there are end effectors, through which a robot can do certain actions and make changes in the environment accordingly. So these are 4 components which are very basic, and it is present in each and every robot. So in sensors, there are different types of sensors, like there is vision sensor, gas, and it can be any kind of sensor according to our requirement and the environment in which the robot is. Later, there are actuators through which the motion is done. One of the example is motors. And later there is end effectors, through which the robot performs certain actions, like it can have certain type of lift arm or a drilling machine in which it need to do certain kind of work or change in an environment. And later, the most important part is microcontroller, through which we can give instruction and program to the robot. So again, these are the few components that we already discussed, and what are its functions and what it can perform. Like in actuators, there are motors, and for sensors, there are input sensors and signal through which the robot can take information in certain environment. And effectors are for example, there are handles which can manipulate and do certain changes in the environment. And lastly, there are microcontrollers, which is the brain of the robot, as it can perform all the instructions that the programmers give. This is the basic diagram of a microcontroller. Like there is processor where the data is stored, and there are certain instruction that needs to be given. There are input and output port. This is the basic diagram of controller. Next we will be discussing about the middleware basics. What is middleware? So middleware is an app. So it is a software that is used to bridge the gap between the application and operating system. It sits between the application and operating system that are on it to provide a communication and data management tool. It works as a hidden translation layer that connects diverse technology, tools, and databases so that it could be integrated seamlessly into a single system. So basically what it does is that it connects operating system and application. It's the middle layer between it. And lastly, we'll discuss about giving robot instructions, the native language of robot, like which language the robot understands. So basically robot understands the language of the microcontroller, and microcontroller uses the machine language. So machine language basically consists of zeros and ones, and that's the only language the robot understands. And there is also assembly language, which is more readable form of machine language, which consists of symbols for instructions and represents binary using hexadecimal and octal notations. So as the machine or a robot get closer to the natural language, the higher the generational designation it receives. So this is all the basic stuff we cleared. Thank you for listening. Thank you.